welcome. I will kind of let some people trickle in here, take a second, and then we'll get started. The constraint on AI progress isn't compute anymore. It's physical infrastructure. Today's bottlenecks are megawatts, molecules, and minerals. Data centers will consume 945 terawatt hours by 2030, more electricity than Japan uses today. You can invest in the companies solving these physical constraints, the next generation of infrastructure that will power AI, support reindustrialization, and secure America's technological independence. From advanced nuclear reactors powering data centers to AI-driven mineral discovery that accelerates extraction by orders of magnitude. These aren't speculative software plays. These are venture-scale opportunities in companies building the essential infrastructure stack that every technology advancement depends on. With the Energy and Strategic Minerals Syndicate, you can gain access to curated deal flow in energy production, storage, distribution, and critical material supply chains. So now, let's hear directly from the VCs on the ground that are sourcing these opportunities. Let's hand it off.
A partner with Alumni Ventures, leading our Energy and Strategic Minerals Syndicate, along with my colleague Mason Hale. We've spent the last couple of years focusing on identifying where the true bottlenecks are for the next frontier of innovation. When most people think about bottlenecks in technology, they may picture faster chips, smarter models, or more efficient algorithms. But we believe the real constraints shaping the next decade are no longer digital, but physical. They'll be measured in megawatts, molecules, and minerals. And that's exactly what we'd like to share with you today. Before we dive in, a quick disclaimer. We are speaking today about Alumni Ventures and our views of the associated investing landscape. This presentation is for information purposes only and is not an offer to buy or sell securities, which are only made pursuant to the formal offering documents of the fund. To give you a quick sense of who you're hearing from today, I graduated from Waterloo in Canada with a degree in mathematics, and I've spent over a decade in investing. Starting on the buy side, covering public equities, then moving into investment banking at JP Morgan. I also spent some time at Riverbed and Upwork before joining Alumni Ventures in 2022 to focus on frontier tech investing. I'll pass the mic over to Mason Hale, my co-presenter, to introduce himself.
Yeah, great to meet y'all. My name's Mason Hale. I've been at Alumni Ventures for about 4.5 years now. Grew up in Houston, Texas, in the oil and gas and energy industry. Ultimately studied energy management at the University of Texas, while also working at a natural gas startup and actually on an oil and gas pipeline in Northeast Ohio. Subsequently, I got a master's in financial engineering from a university in Tokyo, where I was also a kind of a venture scout for 2 different Fortune 100 companies. Ultimately joined Alumni Ventures in 2021 and happy to be talking to y'all today.
Awesome. So together, our team's focus is not just finding great deals, but building a thesis-driven framework that invites all of you to take part in solving the physical bottlenecks of progress. And before diving deeper into the topic, let me give a quick introduction to our firm for those of you who may not be less familiar. Alumni Ventures was founded in 2014 with a simple mission: to make venture capital more accessible. Since then, we've raised over $1.5 billion from roughly 11,000 individual investors and backed more than 1,600 companies, including Grok, Lambda, Cohere, Circle, and Rigetti. Today, Alumni Ventures is one of the most active venture firms globally and the largest VC platform for individual investors in the US. And we have a team of over 120 professionals across major tech hubs, including Silicon Valley, New York, Chicago, and Boston, serving approximately 30 university communities. And our work has earned some recognition across the industry, including being named the top 20 VC by CB Insights, alongside firms like General Catalyst, Khosla, and Sequoia. We've also been recognized by Inc.com as one of the most founder-friendly investors, and more recently ranked number 20 on Time's list of America's top venture capital firms of 2025. While recognition isn't our motivation, we're proud of the validation it provides for our mission, which is empowering individuals to invest in great founders and transformative startups. Now I'll pass it over to Mason to share some exciting new offerings at Alumni Ventures.
Yeah, thanks, Carl. So for those of you interested in joining for the first time, I wanted to take a quick minute to really go over how all of this works before going into more detail about Carl and I's more thematic work. So Carl and I are really excited to introduce the Energy and Critical Minerals Syndicate, which at a high level is an investment approach where you'd be receiving the same energy and critical mineral opportunities that our funds at Alumni Ventures are investing in, but rather than getting it as part of a larger portfolio, you're seeing 1 to 2 curated opportunities per month. And similar to anything we do at Alumni Ventures, we still share our thesis, diligence, market work, et cetera, for you to make the most informed decision for yourself. So pretty straightforward. Joining is totally free. Investing is optional. If a deal resonates, you can participate with a minimum check size of $10,000. And in doing so, you can build a personalized portfolio over time. Think of it as the same institutional access as our funds, but with higher levels of personalization for some of Alumni Ventures' other fund approaches. So now let's get into why Carl and I are both really excited about the emerging opportunities across the physical world. Silicon Valley famously uses the phrase and advice coined by Mark Zuckerberg of Meta to move fast and break things. Engineers are told to ship products quickly, even if they introduce bugs, because the cost of slowing down innovation outweighs the cost of small failures that could be fixed with subsequent software updates. And so while this phrase or even mantra in Silicon Valley was originally directed at the company level, it is now expanded to the entire macro level with the confluence of artificial intelligence, mass electrification and electric vehicles, and automation-focused reindustrialization, alongside a global technology arms race versus China. We're currently living through one of the most technologically accelerated periods in human history, and consequently, we are moving very fast and a lot of things are breaking. And we're already seeing early symptoms of this through rising residential enterprises and these massive physical bottlenecks that are building across the broader economy. And companies that are capitalizing on these new bottlenecks have already yielded tremendous returns, whether that's NVIDIA reaching a $4 trillion valuation by supplying the GPUs in AI infrastructure, or Scale AI, which reached a $30 billion valuation, providing the labeled data to these frontier language model companies. However, unlike many of Silicon Valley's traditional bottlenecks, many of the critical pieces of the economy of tomorrow are breaking under the pure scale of this acceleration, and they can't be fixed with just software updates or merely incremental improvements to existing technologies. So while today's constraints have shifted from the world of code to the world of atoms, what matters now is not really can we train a larger language model, but whether we have enough electricity to do so, enough minerals to build the data centers, and enough infrastructure to sustain all of that. So if data was the new gold of the last decade, access to power is shaping up to be the gold of tomorrow. Or as Mark Zuckerberg puts it rather bluntly, energy, not compute, will be the #1 bottleneck to AI progress. And this idea has been echoed by executives across Amazon, Google, and Microsoft as well, and for good reason. Data center electricity consumption is expected to double to 2030 to more than the entire nation of Japan consumes today. And that estimate came in before OpenAI in the past few weeks announced a 10 gigawatt deal with NVIDIA, 6 gigawatt deal with AMD, and another 10 gigawatt deal with Broadcom to make AI accelerators. And outside of OpenAI too, you have people like Elon Musk at xAI publicly stating that he wants to bring on a full terawatt of compute capacity, which would require roughly the entire electrical power produced in America today. So consequently, these hyperscalers like Microsoft, Amazon, and Google are going to pretty extensive lengths to secure that infrastructure to be able to deliver on this promise of AI. You're seeing everything from the restarting of previously shut down nuclear facilities like Microsoft's 3 Mile Island deal to behind the meter access to energy through natural gas. And this massive acceleration in AI data center build out is hamstrung by more than just access to power. It actually now introduces potential shortages to the critical minerals that serve as the building blocks for AI and the energy grid and infrastructure itself. So to put that into kind of a real world example, US firms currently have over 134 gigawatts of proposed new data center buildouts. And while the numbers roughly can change, usually it's about 27,000 to 65,000 tons of copper per gigawatt. So just that build out alone will require more than 3.5 million metric tons of copper. And that's before we even account for transmission and distribution. And I should mention, copper is one of the most widely used materials in defense systems. It's highly critical in the infrastructure for mass electrification. EV chargers, level 2 chargers contain up to 50 pounds of copper each, with the DC fast chargers often using over 100 pounds. So while we mentioned copper specifically as its usage is well known, there are also looming shortages popping up for other critical minerals that threaten to hamstring innovation. A pretty specific example, if you look at the relatively toxic element beryllium, global processing output is only 300 tons annually, while one fusion reactor can require upwards of 500 tons. So while we illustrate some of these two more specific bottlenecks, it applies to critical minerals and rare earths pretty much across the board. And these bottlenecks are no longer theoretical, as companies solving them will have to potentially create venture scale opportunities to address these issues. And as I mentioned on the previous slide, even though AI is what is currently in the headlines and absolutely causing a massive strain on our current infrastructure, it really is this confluence of many technology shifts that are really being, the straw on the camel's back. Mass electrification of transportation, reindustrialization, and defense modernization, alongside the green transition, are really straining our systems. And our general thesis anticipates this collision and invest in the layers to help relieve these bottlenecks from energy to critical minerals.
So over the past century, national power and GDP scaled with the population, labor, and capital accumulation. But today, the paradigm is definitely shifting. As intelligence and automations advance, the marginal value of human labor is declining. Rather, what really matters now are the megawatts and the materials that power, move, and cool that intelligence. As Mason just mentioned, the real bottleneck to technological progress isn't just compute, but energy and mineral supply at scale. And this leads to a new kind of arms race. And we believe this is no longer optional or niche, but it's essential to economic strength and national defense leadership. Now the race is already well underway, and China holds significant advantages over multiple areas. Let me update you with the latest. China has been far more aggressive in turning power into market impact. For example, installing 6 times more solar capacity than the US last year, while working on 29 additional nuclear plants. It also continues to dominate rare earth, from mining and processing to magnet manufacturing, controlling majority of the world's processed rare earths and magnet output. And the implications are broad. Just last week, China expanded its rare earth export controls. Foreign entities must now obtain a license from Beijing to export any product containing more than 0.1% domestically sourced rare earth or manufacturers using China's extraction, refining, magnet making, or recycling technologies. This marks a major shift from the restrictions on raw materials alone to now including intellectual property and technology, with explicit denials for overseas defense application, as well as case-by-case reviews for semiconductor uses. So for operators and OEMs, the impact could be significant, including licensing delays, higher input volatility, and potential production curves in magnet-intensive sectors such as EVs, data centers, and dual-use supply chains. So China is clearly deploying this as geopolitical leverage, making this not just a financial story, but a national security story. Given the stakes, how is the US reacting? The short answer is more aggressively than ever. The US has declared national energy emergency earlier this year, followed by accelerated permitting and financing. And the most notable recent development is shift from subsidies to equity, moving beyond grants and tax credits to taking direct ownership stakes in critical sectors like rare earths and semiconductors. Over the summer, the government acquired roughly a 15% stake in MP Materials through a $400 million deal, making the DoD the company's largest shareholder and enabling a domestic rare earth magnet buildout. And more recently, US also secured a 10% stake in Trilogy Metals, a Canadian firm developing Alaska's deposits. And these moves reflect a broader rethinking of national security. So rather than merely regulating or subsidizing, the US is now taking an ownership positions to influence priorities, production, scaling, and alignment with the strategic objectives. The orders are clear now. Securing domestic energy and mineral capacity has become a strategic imperative, and we believe some of the most significant venture returns of the coming decade will be generated in this space.
Yeah, so where does that leave us as venture investors? I mean, Silicon Valley often describes things as stacks and layers, where the most topical stack today is often called this AI infrastructure stack. That really forms a pyramid of layers where you, at the top, you have what's called the application layer, which is really your interface to things like ChatGPT and other agents and chatbots. And it goes all the way down to the actual hardware layer itself, which is where you see companies like NVIDIA really excel. And we view this traditional framework as slightly short-sighted and propose to really extend it, the kind of layers and stacks further down to better represent the real bottlenecks of tomorrow's innovation. And so for us, that's these energy layers that power data centers and factories, the critical minerals that make up the semiconductors, electrical infrastructure, and defense systems, down to the companies that are actually leveraging AI and new automated processes to find and extract these minerals. And so without these layers, these LLMs can be too expensive. The factories and data centers won't get built, and we'll continue to pollute our planet by burning fossil fuels and carbon emissions. So to start with really the energy side, broadly speaking, we're looking to invest in energy solutions across time horizons. And this can be roughly bifurcated into two related but separate groups. One is making the most out of the infrastructure and the electrical grid that we have today, making it more efficient, more safe. And the other is investing in the grid and the energy sources of tomorrow. And that includes new energy technologies like nuclear energy and storage. More specifically, Alumni Ventures has been heavily active and early in the nuclear energy sector. And many of you may have seen that the Department of Energy recently selected 10 nuclear fission companies to be part of a program that establishes a new pathway to fast track commercial licensing with the ultimate goal of splitting the atom on US soil in 2026. So we're really excited about that. Of the 10 companies that were selected, 3 of them are Alumni Ventures portfolio companies in Valar Atomics, Allo Atomics, and Radiance. And these startups are on the same list as public companies like Oklo, which is, as of the time of this webinar, had a roughly $20 billion market cap. So really excited to see some of our earlier companies, on the same list as these established players. And I should also add 2 of our portfolio companies, Valar and X Energy, are 2 of the only 4 companies that recently got selected to fast track the nuclear fuel fabrication process, also alongside Oklo. And so while nuclear fission is on the path to come online over the coming years, we're also investing in energy solutions that are, further out from commercialization, more specifically around nuclear fusion. And while nuclear fusion has been 10 years away for a few decades now, a lot of new technologies have been really influential in advancing the field to where it is today. More specifically, artificial intelligence and machine learning are now playing a massive role. So instabilities in plasma are one of the largest operational challenges in a magnetic fusion reactor. And AI is now being used to predict these instabilities in real time so that way control systems can intervene and correct. So fusion companies are now actually making AI accelerated digital twins and physics simulations of these reactors that help them design, plan, and control these systems. So while these companies are using, a different kind of AI model than, say, ChatGPT or a large language model, this physics-informed AI is still leveraging the same massive computational hardware advances in data center build-out that we've seen over the last 10 years. But generation alone is not enough. While this new capacity does get built out, as I said previously, we still need to extract as much capacity and efficiency from today's grid as possible. So some of the areas we're looking at here include robotic pipeline inspection to prevent financially and environmentally costly blowouts in fossil fuel refineries. We're looking at wholesale market optimization platforms that really shape and hedge energy loads. There's also distributed energy orchestration, so customer-sided assets become dispatchable capacity. And then lastly, we're also looking at community solar scaling to help meter and service invisible supply and flex. Altogether, these technologies are improving reliability now. It reduces CapEx per delivered kilowatt hour and buys time for these big grid buildouts that are currently in multi-year interconnection queues. And so I'll now hand it back to Carl to talk more about the critical mineral and mining investment landscape.
Thanks, Mason. So if we want to fix the mineral bottleneck, the first place to look is discovery. Historically, finding an economic site could take a decade, cost hundreds of millions, and still end in a dry hole. But Discovery stack is now being rebuilt with satellites, high-resolution sensing, probabilistic modeling, and surgical drilling, thereby compressing time, capex, and environmental footprint all at once. And AI is a supercharger across all these applications. Satellites and sensors feed geospatial models that can spot anomalies early and narrow down the search, while probabilistic target ranking uses data to pick the next drilled spot and update mine plans faster. And surgical drilling reduces waste and water use and feeds quality data back into the model, so every meter drilled improves prediction. The result is much faster cycles, lower costs and footprints, and a cleaner path from anomaly to bankable resource. Why this matters for the thesis is that the discovery is a rate limiter upstream. If we can 10x the learning per meter or 10x the surface area scanned per dollar, we pull the entire supply curve forward, which the downstream economies such as EVs or the AI data centers desperately need. And this is exactly the kind of layer becoming a toll booth shift we're looking for. But the finding resources is only half the job. The next challenge is extracting, concentrating, and refining materials profitably, cleanly, and close to where they're needed. The next generation leaders leverage innovative tech to redefine the economics of the process. For example, ion exchange pulls lithium from brines faster with higher recovery and much less water. And electro extraction recovers nickel, cobalt, and other metals from tailings or low-grade ore without high-temperature smelting, turning waste rock into usable feedstock. While biochemical methods provide cleaner, more selective ways to produce high-purity rare earth, and autonomous seabed harvests can target a specific area while minimizing damage to the ocean floor. Looking at the big picture, if the discovery expands the map, next-gen extraction and refining determines what portion of that map becomes commercially viable and how quickly they can be. These platforms collapse time to first product, tame capex, and reduce permitting friction and localize processing for resilience. But even with the faster discovery and cleaner refining, the easiest and perhaps least controversial supply may come from materials already in use. That's why we would treat recycling as a core source, not just an ESG checkbox. It's the fastest way to secure magnets, batteries, and conductors for AI, EVs, and the grid. So the companies like Ascend Elements, Graduate Materials, and Cycling Materials are building closed-loop systems to recover critical and rare earth materials from old batteries, electronics, and motors. And recycling isn't just about sustainability. It's a strategic part of supply security. It's faster, faces fewer permitting hurdles, can be more domestic, and helps with price stability. Now I'll hand it back to Mason to bring us home.
Yeah, I mean, really to summarize what we've said today across energy and minerals, it really is about fix the infrastructure we have today, but invest for the infrastructure tomorrow. We're in one of the most accelerated technology transitions in human history, and on the cusp of commercializing technologies that can reshape human civilization, whether that's AI, robotic autonomy, clean and cheaper nuclear energy, or fully self-driving electric cars. And to put into scale how big these technology markets that we're disrupting are, I mean, the global energy market's around $6 trillion, transportation over $8 trillion. AI is coming for knowledge work itself, which is a much more nebulous estimate, but to ballpark it, knowledge-intensive employment in advanced economies is 30 to 40% of all labor income. And so these markets are absolutely massive, but we can't meet the promise of these technologies if we're power or mineral constrained. So the Energy and Critical Minerals Syndicate is really investing in companies that grease the skids for this upcoming technology revolutions. And we're looking for companies solving these critical bottlenecks and that become embedded into these massive and growing markets, creating defensible moats across technical complexity, sometimes regulatory approvals for companies like in the nuclear space, and really data flywheel moats. And these companies that are critical to national security and driving policy tailwinds as well. So portfolio strategy is pretty clear. We want to back founders solving these constraints, focus on scalable and capital efficient solutions, often aligning with national security priorities, and ultimately to just build the infrastructure for AI and reindustrialization. Yep. So if these themes speak to you, we invite you to join our Energy and Strategics Minerals Syndicate. Once again, joining is free and investing is optional. As a member, you'll review deal opportunities as they arise, participate in curated events with entrepreneurs and thought leaders, and have the option to invest in startups solving the energy, storage, distribution, and critical mineral problems of today and tomorrow. So if you're interested, you can reach out to me directly at mason.hale@av.vc or to carl@av.vc. I'm based out of New York. Carl's based out of the Bay Area, so feel free to reach out if you want to get involved with the syndicate, events, or Alumni Ventures broader expert community, which directly help the specific companies within our portfolio. Maybe just to kind of close this out, if you want to just zoom back out, for decades, the bottlenecks to progress were really abstractions and things solved with code and compute. Today and tomorrow, these bottlenecks have shifted to megawatts and minerals, and whoever solves them will not only capture enormous economic value, but also define the trajectory of innovation itself. And so ultimately, that's what really excites Carl and I, drives most of our work here, and that's what we would love to invite you to be a part of. So once again, thank you everyone for coming and attending today, and feel free to reach out to either Carl or myself if you have any further questions.
Thanks, everyone.
Okay. Sweet. That was great. AI's future doesn't run on code. It runs on power, minerals, and the infrastructure we build today. Thank you for joining us, and if you're ready to back the companies that will keep innovation running and nations competitive, scan the QR code or visit av.vc to join the Energy and Strategic Materials Syndicate. And as always, we will see you next time.